Cloud computing. Cloud computing refers to the use of hosted services, such as data storage, servers, databases, networking, and software over the internet. The data is stored on physical servers, which are maintained by a cloud service provider. Computer system resources, especially data storage and computing power, are available on demand, without direct management by the user in cloud computing. Definition: cloud computing refers to the delivery of computing services, including storage, processing power, and software over the internet. Upload: you upload your photos to the cloud service, which stores them on remote servers. Access anywhere: now you can access your photos from any device with an internet connection, your computer, phone, or tablet. Share: you share a link with your friends. They can view, download, or even collaborate on the photos without needing to have the files physically on their devices. Types of cloud computing. Private cloud. Definition: in a private cloud, computing services are exclusively offered over a private IT network dedicated to a single organization. Also known as internal, enterprise, or corporate cloud, it is managed internally and not accessible to external entities. Public cloud. Definition: public cloud refers to computing services provided by third-party providers over the internet. These services are available to anyone and can be free or sold on demand, with users paying for actual usage. Hybrid cloud. Definition: hybrid cloud combines features of both public and private clouds, allowing workloads to shift between them based on computing. This model provides flexibility and scalability. Cloud computing can either be classified based on the deployment model or the type of service. Based on the specific deployment model, we can classify cloud as public, private, and hybrid cloud. At the same time, it can be classified as infrastructure as a service, platform as a service, and software as a service based on the service the cloud model offers. What are IaaS, PaaS, and SaaS? IaaS, PaaS, and SaaS are the three most popular types of cloud service offerings. They are sometimes referred to as cloud service models or cloud computing service models. IaaS, or infrastructure as a service, is on-demand access to cloud host storage and networking, the back-end IT infrastructure for running applications and workloads in the cloud. PaaS, or platform as a service, is on-demand access to a complete, ready-to-use, cloud-hosted platform for developing, running, maintaining, and managing applications. SaaS, or software as a service, is on-demand access to ready-to-use, cloud-hosted application software. IaaS, PaaS, and SaaS are not mutually exclusive. Many mid-sized businesses use more than one, and most large enterprises use all three. Advantages of cloud computing. Cost savings. Pay-as-you-go model. Scalability. On-demand resources. Flexibility. Wide range of services. Accessibility. Anywhere, anytime access. Collaboration efficiency. Remote collaboration. Automatic updates. Managed services. Reliability and redundancy. High availability. Security features. Data encryption, identity, and access management. Disadvantages. Limited customization and control, less control over infrastructure configurations. Data privacy concerns, compliance challenges with privacy regulations. Disadvantages of cloud computing. Security concerns, risk of data breaches and unauthorized access. Downtime and service outages, dependency on internet connectivity. Dependency on internet connectivity, reliance on stable and high-speed internet. Quantum computing is a multidisciplinary field comprising aspects of computer science, physics, and mathematics that utilizes quantum mechanics to solve complex problems faster than on classical computers. The field of quantum computing includes hardware research and application development. Quantum computers are able to solve certain types of problems faster than classical computers by taking advantage of quantum mechanical effects, such as superposition and quantum interference. Some applications where quantum computers can provide such a speed boost include machine learning, optimization, and simulation of physical systems. Eventual use cases could be portfolio optimization in finance or the simulation of chemical systems, solving problems that are currently impossible for even the most powerful supercomputers on the market. What is the quantum computing advantage? Currently, no quantum computer can perform a useful task faster, cheaper, or more efficiently than a classical computer. Quantum advantage is the threshold where we have built a quantum system that can perform operations that the best possible classical computer cannot simulate in any kind of reasonable time. What is quantum mechanics? Quantum mechanics is the area of physics that studies the behavior of particles at a microscopic level. At subatomic levels, the equations that describe how particles behave is different from those that describe the macroscopic world around us. Quantum computers take advantage of these behaviors to perform computations in a completely new way. What is a qubit? Quantum bits, or qubits, are represented by quantum particles. The manipulation of qubits by control devices is at the core of a quantum computer's processing power. Qubits in quantum computers are analogous to bits in classical computers. At its core, a classical machine's processor does all its work by manipulating bits. Similarly, the quantum processor does all its work by processing qubits. How are qubits different from classical bits? In classical computing, a bit is an electronic signal that is either on or off. The value of the classical bit can thus be 1 or 0. However, because the qubit is based on the laws of quantum mechanics, it can be placed in a superposition of states. What are the principles of quantum computing? A quantum computer works using quantum principles. Quantum principles require a new dictionary of terms to be fully understood, terms that include superposition, entanglement, and decoherence. Let's understand these principles below. Superposition. Superposition states that, much like waves in classical physics, you can add 2 or more quantum states and the result will be another valid quantum state. Conversely, you can also represent every quantum state as a sum of 2 or more other distinct states. This superposition of qubits gives quantum computers their inherent parallelism, allowing them to process millions of operations simultaneously. Entanglement. Quantum entanglement occurs when 2 systems link so closely that knowledge about one gives you immediate knowledge about the other, no matter how far apart they are. Quantum processors can draw conclusions about one particle by measuring another one. For example, they can determine that if one qubit spins upward, the other will always spin downward, and vice versa. Quantum entanglement allows quantum computers to solve complex problems faster. When a quantum state is measured, the wave function collapses and you measure the state as either a 0 or a 1. In this known or deterministic state, the qubit acts as a classical bit. Entanglement is the ability of qubits to correlate their state with other qubits. Decoherence. Decoherence is the loss of the quantum state in a qubit. Environmental factors, like radiation, can cause the quantum state of the qubits to collapse. A large engineering challenge in constructing a quantum computer is designing the various features that attempt to delay decoherence of the state. What are the components of a quantum computer? Quantum computers have hardware and software, similar to a classical computer. Quantum hardware. Quantum hardware has 3 main components. Quantum data plane. The quantum data plane is the core of the quantum computer and includes the physical qubits and the structures required to hold them in place. Control and measurement plane. The control and measurement plane converts digital signals into analog or wave control signals. These analog signals perform the operations on the qubits in the quantum data plane. Control processor plane and host processor. The control processor plane implements the quantum algorithm or sequence of operations. The host processor interacts with the quantum software and provides a digital signal or classical bit sequence to the control and measurement plane. Quantum software. Quantum software implements unique quantum algorithms using quantum circuits. A quantum circuit is a computing routine that defines a series of logical quantum operations on the underlying qubits. Developers can use various software development tools and libraries to code quantum algorithms. What are the types of quantum technology? No one has shown the best way to build a fault-tolerant quantum computer, and multiple companies and research groups are investigating different types of qubits. We give a brief example of some of these qubit technologies below. Gate-based ion trap processors. A gate-based quantum computer is a device that takes input data and transforms it according to a predefined unitary operation. The operation is typically represented by a quantum circuit and is analogous to gate operations in traditional electronics. However, quantum gates are totally different from electronic gates. Trapped ion quantum computers implement qubits using electronic states of charged atoms called ions. The ions are confined and suspended above the microfabricated trap using electromagnetic fields. Trapped ion-based systems apply quantum gates using lasers to manipulate the electronic state of the ion. Trapped ion qubits use atoms that come from nature rather than manufacturing the qubits synthetically. Gate-based superconducting processors. Superconductivity is a set of physical properties that you can observe in certain materials like mercury and helium at very low temperatures. In these materials, you can observe a characteristic critical temperature below which electrical resistance is zero and magnetic flux fields are expelled. An electric current through a loop of superconducting wire can persist indefinitely with no power source. Superconducting quantum computing is an implementation of a quantum computer in superconducting electronic circuits. Superconducting qubits are built with superconducting electric circuits that operate at cryogenic temperatures. Photonic processors. A quantum photonic processor is a device that manipulates light for computations. Photonic quantum computers use quantum light sources that emit squeezed light pulses with qubit equivalents that correspond to modes of a continuous operator, such as position or momentum. Neutral atom processors. Neutral atom qubit technology is similar to trapped ion technology. However, it uses light instead of electromagnetic forces to trap the qubit and hold it in position. The atoms are not charged and the circuits can operate at room temperatures. Rydberg atom processors. A Rydberg atom is an excited atom with one or more electrons that are further away from the nucleus on average. Rydberg atoms have a number of peculiar properties, including an exaggerated response to electric and magnetic fields and long life. When used as qubits, they offer strong and controllable atomic interactions that you can tune by selecting different states. Quantum annealers. Quantum annealing uses a physical process to place a quantum system's qubits in an absolute energy minimum. From there, the hardware gently alters the system's configuration so that its energy landscape reflects the problem that needs to be solved. Computing. Quantum computing can revolutionize industries. We give some example use cases below. ML. Machine learning is the process of analyzing vast quantities of data to help computers make better predictions and decisions. Research in quantum computing studies the physical limits of information processing and is breaking new ground in fundamental physics. This research leads to advances in many fields of science and industry, such as chemistry, optimization, and molecular simulation. It is also a growing area of interest for financial services to predict market movements and for manufacturing to improve operations. Optimization. Quantum computing can improve research and development, supply chain optimization, and production. For example, you could apply quantum computing to decrease manufacturing process, related costs, and shorten cycle times by optimizing elements such as path planning in complex processes. Another application is the quantum optimization of loan portfolios so that lenders can free up capital, lower interest rates, and improve their offerings. Simulation. The computational effort required to simulate systems accurately scales exponentially with the complexity of drug molecules and materials. Even using approximation methods, current supercomputers cannot achieve the level of accuracy that these simulations demand. Quantum computation has the potential to solve some of the most challenging computational problems faced in chemistry, allowing the scientific community to do chemical simulations that are intractable today. For example, Pascal built their Cubic computational software to run chemistry simulations. Cubic automates the heavy lifting necessary to run quantum computational tasks, from automatic provisioning of the computing infrastructure to running pre- and post-processing classical calculations, and performing error mitigation tasks. How can you get started with quantum computing? If you want to try quantum computing, you can get started with a quantum hardware emulator on your local machine. Emulators are regular software that imitates quantum behavior on a classical computer. They are predictable and allow you to see quantum states. They are useful if you want to test your algorithms before investing in quantum hardware time. However, they cannot recreate real quantum behavior. You can also use a cloud quantum computing service to code on a true quantum computer without investing in expensive hardware. How can AWS help with quantum computing? Amazon Breakit is a fully managed quantum computing service. It is designed to help speed up scientific research and software development for quantum computing. You can use Amazon Breakit to do these tasks. Work with different types of quantum computers and circuit simulators using a consistent set of development tools. Build quantum projects on a trusted cloud with straightforward pricing and management controls for both quantum and classical technology. Innovate quickly with expert guidance and tech support, or collaborate with consultants in the Amazon Quantum Solutions Lab. Push the boundaries of quantum hardware research with access to trapped ion, superconducting, photonic, and annealing devices. I hope you got a good knowledge. See you in another video. Have a nice stay with Highly Multimedia 2024.